All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 76 is on your screen. That shouldn't be a problem. The only thing I'm bringing back again, the cubic functions for number 2. And the rest is a recap of what we've been doing so far. I'll give you some time. Copy and go. All right. So, number 1. What'd you get for number 1, please? Christopher, what'd you get for number 1? Approximately 4.4. Hands, if you got that? That is correct. Thank you. Let's go to number 2. Let me make some space underneath. Let's see. Number 2. And I'll go ahead and do this one just for the fact that, just to recap, here's my coordinate plane. All right. So then my parent function is at 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, 8, negative 8, sorry. And it looks like this. So far so good, yes? And then we substitute values into here. So we substitute 1 there, 2 here, and 5 there. So the ones basically are not used. So I'm just going to rewrite this as g of x equals parentheses x minus 2 cubed plus 5. So that's going to take this whole function to a new vertex. Before it was at 0, 0. Where's it going to be at now? What's our new vertex? Sorry, neighbor, please, so I can call on Diego. What's our new vertex? All right, Diego Romo, new vertex. Yeah, 2, 5. And I don't know if you guys seen from last week to now, we continue using the vertex, or in other words, the x value now it's an h. There it is. And the y value now is the k. So 2, 5 is somewhere up here. So my new vertex, which is this one's going to move up here, which means I have a point there, there, and then another one down here, and another one up here. So it moves the whole thing something like that. That's my g of x. All right. All right, move on. Number 3, completing the square. So let's see if we remember. We set it to 0, standard form, x squared minus 8x plus 20. From there, we divide by the leading coefficient. What's my leading coefficient, guys? An invisible 1. So we end up with x squared minus 8x plus 20 equal to 0. From there we eliminate, there's a square. We eliminate the constant, so we subtract 20, and we're left with x squared minus 8x, empty space, equals to negative 20. So you never what to do from there, please. What do we do from there? All right, help me out, Frida. What do I do from there? Negative 8 over 2 squared to both sides. Thank you. Negative 8 over 2 squared to both sides. We end up with x squared minus 8x plus 16 equals negative 20 plus 16. I'm going to simplify the right side to negative 4. And then we end up still with x squared minus 8x plus 16. Then we need to find the factors of this trinomial. So, something squared. What'd you get there, Jessica? X squared is x. Square root of 16 is 4, and then the sign of the middle. Yes, there it is. And the last steps, we need to leave x by itself, so square root, we end up with x minus 4 equals plus minus. What is square root of negative 4, everyone? To what? 2I, yes. And then last but not least, solve for x, plus 4 plus 4. Our solution is x equals 4 plus minus 2I. Let me write it over here. X equals 4 plus minus 2I. And this is two solutions. However, they're not real solutions. Is that correct? Not real because they have an imaginary number right here. These are known as complex or non-real or imaginary. All right. So far so good? Yes, Mr. Q. All right. And last but not least, let's move on to number 4. Number 4. All right. So for this one, we got our voltage formula equals to I times Z. So voltage equals, we need to substitute for the current being 24 plus 12I, and then the impedance, which is Z. They're talking about the inductor. Tell me, neighbor, which one is the inductor of all of those, please? Which is the inductor? All right. Alessandro, which one? The squiggly one? This one? The other squiggly. So this one. That is correct, and we write it as an imaginary. That is 3I. Distribute, that's 72I. Distribute, that's 36I squared. However, instead of I squared, what do we do, guys? Negative 1. So 36 times negative 1 is negative 36. And then we bring the 72I to the end, so that's plus 72I. And that is the voltage going through the inductor. All right? How we doing? Good? Yes, Mr. Q. All right. So with that said, send me your warm-ups, please. Bless you. Agenda for today, warm-up number 76. Distance formula. Home play is only 10 problems. Only. And I'm working on editing last week's, Friday's session. I had difficulty with technology. If I can't do that after lunch, then I'm probably going to do without that video, but we'll continue with this one. So, so we're wrapping up. Last week we wrapped up with quadratic equations, and today we're moving on to distance formula. And like I said, today's session is probably going to be the easiest one of second semester because I'm just going to transfer stuff that you should know that you covered from maybe 5th, 6th, 7th grade and transferring that to now to where we're at with Algebra 2. Okay? So, last week's home play was, on Friday's home play was pages 146, 147. That's the gift from me to you. Thank you, Mr. Q. However, take a picture of those 10 problems, please. That's tonight's home plate. All right. All right. So, with that said, copy the objective. I can derive the distance formula and compute the distance between 2 points. I can derive the distance formula and compute the distance between 2 points. All right? I can derive the distance formula and compute the distance between 2 points. What's the main concept for today? Distance formula. We don't need a Faraday model because I'm actually going to explain a couple of things so that you can see the main idea. Okay? Yes, yes, yes. All right. Here we go. So, write your pencils down, look up to the screen really quick. I'll have you go back to where we're at on your notes, but look up to the screen. And if you notice, I placed a right triangle. Don't copy this. It's just a review. A right triangle on the screen. Tell your neighbor why it's a right triangle, please. Why is it a right triangle, Jaden? Because it's very, very smart and it's always right? Nah. Yeah, it's got a right angle right here, 90 degrees. All right. So with that said, I'm going to label the sides with values. Here it goes. I got the height being 3, the base being 4, and the longest side 5. Okay. So I'm going to find a relationship between these 3 sides, but using the side and making an area of each side. So here we go. And I'm pretty sure you've seen this before, but just in case, there it is again. So, talk it over to your neighbor, let them know what relationship do we find between this one. Actually, before that, how many squares did we get here? This is how many? 1, 2, 3, 9. Okay. How about over here? 16. Okay. How about over here? 25. All right. So we started with 3, 4, and 5. Now we have 9, 16, and 25. Tell me never any relationship that you see. What do you see? Any relationship? All right, so let's see. How do we get from here, from 3, 4, 5 to 9, 16, and 25, everyone? Yes, squared, squared, and squared. Okay. Next, we're here now, now that we squared it. Do you see any relationship here? What is it? They're perfect squares, yes. That's good. Anything else? Anyone see it? Talk it over to your neighbor, let them know what you see. Anybody, what you see? What do you think, Joel? Anything? Anaya, what do you think? Juan? JP, what do you see? 9 plus 16, you get 25. That is correct. Which means 3 squared plus 4 squared equals 5 squared. Does that sound familiar? Yes, that's exactly it. This is from 5th, 6th, 7th grade. Write this down. The Pythagorean theorem. That is correct. I'm just showing you the connection where it came from in regards to coordinate and graphs and such, and connecting it to your geo career over here at IHS. So we got a squared plus b squared equals c squared. And then sketch a little triangle over here on the side, a 90-degree triangle. And I usually use red for this one, and I label this one A. I usually use green for this one, and I label this one B. And this one over here, I usually label C. And just to double check, this is a 90-degree angle. That's why this is a right triangle. And the side that's across from the 90-degree angle is known as the hypotenuse. And it's usually the longest side, Okay? So the Pythagorean theorem works with all right triangles. Okay? So this, like I said, quick recap from elementary and middle school. So copy this, example 1Q. Copy that one. And we have a right triangle where the base is 15 centimeters, the height is 8 centimeters, and the longest side is labeled C. All right, so let's walk through this process. When they give us a triangle like so, and they want us to find the side that the side measure that's missing for right triangles, we use a Pythagorean theorem. So we start with a squared plus b squared equals c squared. So I'm going to label the base A and the height B, and the other one's already C. So A squared and A is 15 squared. So what is 15 squared, everyone? 225, very good. Plus 8 squared is 64. And all that equal to c squared. All right, continue. 225 plus 64, that's 289 equals c squared. But we still need to solve for c, and we need to cancel this squared, everyone. Square root, c equals, and by now, as we mentioned last week, since we're dealing with distances and time, we no longer use the negative part of the square root. We only use the positive. So square root of 289 is 17. So label that equal to 17 centimeters. All right, send me your note. All right, check with the neighbors, see what they got. They should be done by now or close to done. All right, for the sake of notes, let's see. Should have labeled this A, B, C, and then we got A squared plus B squared equals C squared. Then we got 40 squared plus 30 squared equals C squared. So we got 1600, 900, C squared. This is 2500 equals C squared, square root. So 50 equals C. So this is 50 feet. 50 feet. All right, send me your notes. All right, copy example 1 MegaQ, and it reads, compute the distance between the points 2, 8, and 4, 4. 2, 8, and 4, 4. 2, 8, and 4, 4. All right, so let's plot those points, 2, 8, and 4, 4. And they want what? The distance between those 2 points. So I'm going to label that D for distance. Now, look at it and show your neighbor where you see the triangle forming with that component. Do you guys see the triangle? You guys see it? Yes? All right, so in red, I'm going to do the base of the triangle and label that how many units? 2. All right. In green, I'm going to do the height, and I'm going to label that 1, 2, 3, 4 units. There it is. And of course, what do we use to find the distance between the 2 points? The Pythagorean theorem. We got a squared plus b squared equals c squared. All right, help me out with this one, please. Diego Rosas, what do I write? Yes, 2 squared plus 4 squared equals d squared. Okay. So let me just change colors in case you didn't see it. All right, so 2 squared is 4. 4 squared is 16 equals to d squared. So this is 20 equals d squared. How do we cancel the squared, everyone? Square root. So square root of 20 is equal to d. And this is what? Exact. However, I want to know approximately how much is d. So find the approximation, please. Approximately, how much is that? All right. JP? We'll leave it at 4.4. Hands, if you got 4.4? Looks about right. Okay. All right. From 1 to 5, comfortable are you with these? Yeah, we got this. Yeah. Okay. Now check this out. In passing, write your utensils down, look up to your screen. Let me look at the base. Now, it's obvious just by counting squares, this is 2 units, right? However, look up to the screen, you're going to miss it. If I look at it through the coordinates, what is the x coordinate for this point right here? The x coordinate is 2, or the x value. How about for this point, what is the value here? 4. What can we do with those 2 numbers to get 2? Subtract, right? But we start with this number over here, 4, and then we subtract what? The 1 to the left, which is 2. Okay. Same idea for the height. Look at it. The height, once again, I can count the steps, 1, 2, 3, 4, or looking at the y value for this point down here is 4. The y value for this one is 4. And how do I use those numbers to get 4? Well, 8, which is the one on top, minus 4, and that's how we get 4. All right? So, think we got it? Yes? Yes, Mr. Q? All right. So, send me your notes. All right, for this next one, you can use the same coordinate plane, so you don't have to make another one. But on the side or to the other side, just write example 1, Michael, Jordan, Q. You're going to find the distance between 5, 5 and 8, 9. 5, 5 and 8, 9. Like I said, you can use the same coordinate plane to save time. So 5, 5 and 8, 9. So let's plot 5, 5. You all right over there, Fredo? Okay. 5, 5. I thought your book was about to leave your desk or something. 8, 9. 8, 9. And they want the distance, so that means from here to here. And what do we label that, everyone? D for distance, okay. And the base, you guys see the base? Yes. Right there. And that's how many units? 3. And the height? How many units? 1, 2, 3, 4. Okay. And the rest is history, yes? A squared plus B squared equals C squared. And I'll give you guys time to finish that. And go. So I think we got it, yes? Yes, it's you. So, what'd you get for D? Hey, Delilah. 5. Hands if you got that. That is correct. Okay. Now, just to make sure we understand what we're looking at, we're using the Pythagorean theorem to find the distance. However, if I was to ask you to use coordinates, let's see, Diego's going to elaborate on this for us. Let's say this was 5 and this was 8. Oh, sorry. For the base, 5 and 8. How do we find this distance using those two numbers, Diego? You subtract the one farthest to the right from the smallest, and then how about the height? We got 5 and 9. Yes, okay, we got it, right? Okay, so with that said, copy this one. Exactly how it is, without any numbers or anything on it, just a coordinate plane like so. Go ahead. All right, here we go. I'm going to place a point right there and another one right there. And we're going to find the distance. And let's say this point, the x-coordinate is x sub 1, and this one is x sub 2. I'm sorry, y sub 1, I'm sorry. Y sub 1. Y sub 1. Okay. The second point up here, it's x sub 2. And the y value is y sub 2. All right. So, let's see. Diego was elaborating earlier in regards to how to find the base and the height. Let's start with the height. So the height for our triangle, what would I write now for the height, Diego? What do I write to find the distance for the height? Right, but what do I do? Yeah, y2 minus y1, that is correct. Write that in there, please. So that means that for the base, hey neighbor, what we need to write for the base, guys? For the base. All right. What do we write, Christina? x2 minus x1. All right. So, with that said, let's write our Pythagorean theorem over here on the side. A squared plus b squared equals c squared. We know that the c is d squared by now. Give me a second. So, let's substitute for a, parentheses, x sub 2 minus x sub 1 squared plus, for b, y sub 2 minus y sub 1 squared. Have a good day. All right. However, we're still not done because we need to solve for what? The distance, right? So we need to leave b by itself. So what do we do at the end, everyone? Square root. Square root. So we're going to write square root equals to d. So we got parentheses x sub 2 minus x sub 1 squared and y sub 2 minus y sub 1 squared. And my peeps, this is what we call the distance formula. Distance formula. So for tonight's home plate, when I ask you to find the distance between 2 points, I don't want a graph. I don't want you to count steps. I want you to use what? The distance formula. Now, before moving on, tell your neighbor where we got the distance formula from. See if they understand it, please. Yeah, so you see, guys, all the basic stuff and foundational stuff that your other teachers did from elementary to 7th grade, 8th grade, then geo, all that came to play now because now that we're transferring all that into Algebra 2 stuff. So with that said, send me your notes for that really quick. All right, example number 2, compute the distance between the points 2, 3, and 5, 7. 2, 3, and 5, 7. Let's do this one together so you guys can see exactly what to do. So first things first, they want the distance. That means you write your formula. D equals square root, parentheses, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Then you rewrite it again, but with blanks. D equals square root, parentheses squared with a negative in the middle, plus parentheses squared with a negative in the middle. All right. So assume by looking at these two coordinates that they give us that the first one, 2, 3, is point number 1. I'm going to put a little Roman numeral on top. And the second one is point number 2. With that said, that gives us now stuff to label. So if this is point 1, we're going to label this x sub 1. And the other one over here, the 5, is the x sub 2. So now we substitute that into our formula, 5 and 2. Which means that if this is point 1, that means we got 3 is y sub 1 and 7 is y sub 2. So we write that in here, 7 and 3. All right, and the rest is history. Square root. What is 5 minus 2? That's 3 squared plus 7 minus 3, 4 squared. D equals square root of, this is 9 plus 16. What is 9 plus 16? Square root of 25. What is square root of 25? 5. Ooh-wee. From 1 to 5, how comfortable are you with that? Yeah, 5s, right? Like I said, this would be probably the easiest one of them all. All right, send me your work, please. Oh, never mind. I didn't open one for that one. Copy this one, example 2Q. This one, you are going to send me your work for this one. It says compute the distance between the points 2, 1 and 6, 4 using the formula. And then send me your work. All right, looks like everybody got this. Let's see, something like that. D equals 5. Hands if you got that. Yeah. All right, we'll stop right there. So hopefully for tonight is going to be pretty much this, what we did at the end, to make sure you practice your home play, and we're moving on tomorrow. I'll stop for the video right there.